Before we begin, my name's Jack. I'm the product manager on the Cosmos SDK over at Tendermint. I've been there for a little while, and obviously we've been focused quite a bit on launch here. So just a show of hands to kind of level set here, who has worked with any of our products before? Tendermint, Cosmos, the Cosmos SDK. Okay, cool. Who else has developed on top of other blockchains? Ethereum folks primarily? Bitcoin? Cool. Awesome. So good general level of blockchain knowledge in here. So what I'm going to be talking about today is how to use the Cosmos SDK to make a replicated state machine, or a blockchain, as we'll call it. At a high level, so what is our initial state? That's a question we're going to have to answer as we're building this replicated state machine. Where does it start from? What are the possible state transitions? How can that state mutate? And then is it Byzantine fault tolerant, i.e. the nodes that it's living on, are they able to resist malicious actors? So at a high level, the Cosmos SDK sits on top of Tendermint, which is a Byzantine fault tolerant state machine, which takes care of a lot of the kind of magic, the P2P stuff, all of the persistence, the creation of the blockchain network, and the addition of new blocks is all taken care of in Tendermint itself. And that communicates with your application via something called ABCI, your Application Blockchain Interface. And all of your state transitions and other state mutations will all be defined within this application we're building. So what does this allow you to do? It allows you to take a step back from the underlying internals and really focus on what you want the user interface of your app to be, i.e. what actions do we expect users to perform, and how do those actions mutate state. So there's this focus on the application. You can think of Ruby on Rails for blockchains. It's also proof of stake. So in prior generations, if you were looking to build your own blockchain, you'd probably fork Bitcoin or fork Dogecoin, depending on how adventurous you are, and use one of these proof of work currencies to create a blockchain. We're really the first SDK that allows you to do this in a proof of stake system. And as I mentioned earlier, Tendermint for consensus and networking. I'll also pause right here. If anyone has any questions during this presentation, please just shoot your hand up. I'll be happy to answer those. Yeah. So what are we building today? If any of you are familiar with the history of the blockchain space, you'd be familiar with some of these blockchain naming systems. The Occam folks over there are building one for IoT devices. This is an active area of research and an active area of development for many of these blockchain systems. So the Ethereum naming service, Handshake, both run on top of Ethereum, are examples of this. They essentially map a human-readable identifier to a public key, very similar to the domain name service. The earliest example of this was Namecoin, that eventually became a company called Blockstack. I actually spent about a year at Blockstack and helped them raise their ICO too, so this is near and dear to my heart. Yeah. So as I mentioned earlier at the beginning, here's the GitHub. If you want to download the tutorial and follow along with the code, that's probably the best way to get the most out of this. And at the end, I've got a node spun up with the network, and we'll be able to bid on some names and steal them from each other, and hopefully it's fun. That's at least the game plan. But in this, what we're creating, you'll be able to outbid somebody for a name. So if somebody pays, let's say, 5 tokens for a name, and you bid 6 for it, you become the new owner. So a fun little bidding war can develop. So if we're talking about the SDK at a high level, it's this modular framework. And what do we mean by that? So if we go back to this idea of a replicated state machine, and we're defining these state transitions that users can make, there are groups of these state transitions that are kind of thematic. So in the SDK, we give users the staking module. This defines some advanced staking and slashing behavior. So a couple of folks were talking about downtime slashing, or when a validator double signs or presents some malicious behavior towards the network, we'll penalize that validator by taking away their tokens. So that's one example of a module. Distribution, another example of a module. In the hub software, we have inflation. that rewards folks who stake tokens with those newly minted tokens, and they're distributed to all the validators evenly. So that's a module. The ability to use tokens, and we'll see a few more examples. And the core of this tutorial is building our own module, which is just going to be a group of state transitions. Any questions there? All right. So the modules in this tutorial, auth. So this is the Cosmos SDK by default is an account-based blockchain. So you can think of something like Ethereum rather than a UTXO-based blockchain like something like Dogecoin or a Bitcoin, obviously the first one. And then there's bank, which is closely paired with auth. So keeping track of the amount of tokens. Obviously, when we were talking about the state machine and a starting state, there might be a starting state with some number of tokens in it, money, money, money. And then our name service is the other module that's going to be in this. And we'll build this. And this is essentially maps a name to some data. So in the DNS service, that's a zone file. And it's going to be roughly the same thing here. So staking, I spoke about just a few seconds ago. That's one of the major modules that we have in the hub. You could add it to this tutorial. I've omitted it for clarity and lack of complexity. But this would give you that sort of advanced staking logic. And what's interesting is without staking, the Cosmos chain is kind of this private permissioned chain where you need to know somebody on it to join as a validator. Our staking module in the hub, the one that's publicly available, is designed to be a public staking module so that it's this permissionless staking system. And you can build both of those with Tendermint and the SDK. And then another one that is not in there is governance. If you guys have been following the project at all lately, you know that we've got a couple of governance proposals up to upgrade the project. So that's how we're doing governance in the chain. And if anyone has questions on those, I'm happy to answer them at the end as well. So modules control state, and you define messages in those modules. So at a high level, when we're thinking about the Cosmos SDK, I mentioned that there's the application that kind of lives on top, and then there's Tendermint below it. There's a piece of the SDK that governs communication between Tendermint and your application, and that's called base app. And the store that it has on disk is something we call the multi-store. And it just has a bunch of different key value stores, so you can think of like a name to value mapping. Just very simple stuff. Or in the case of validators in the staking module, there's a validator to the amount of power it has. And these simple primitives, with that, you can build up much more complex applications. It's just a KV store like any other database. Any questions there? Cool. And then the state balances in bank, which accounts exist, and then domain names. So pretty simple state here. We're not going to really dig into the details on accounts and balances, but we will dig into the details on the domain names. So what will we be storing in this store that we've created? For this name service, we've got 3 mappings here. One from name to value. What does the name resolve to? I.e., its zone file or the... I mean, just like an A record, it would come out to some IP address. So I think that's the example that we show, is it resolving to an IP address. But it could be a fully RFC compliant zone file pretty easily. It's just a string. Another mapping is name to owner, i.e. what name is owned by what wallet. And then we're going to use a public key there. And then another mapping is from the name to the price. So how much was paid for the name? And I was talking about this bidding component to this, so that's obviously important as well. Now, one other way we could do this, if you'll notice they're all name to something mappings. You could have name to complex object mapping that contains all of the other data. That's left as an exercise for the user. If you guys want to modify the tutorial, that's a pretty easy refactor that helps you understand the code a little bit better. In the SDK, we have transactions, and each transaction that goes into a Cosmos SDK application can contain many messages. So when we're talking about these user-facing methods that are going to be called, we're talking about messages. Messages are routed through handlers. Handlers hand those messages to keepers. this is the sort of like higher level object hierarchy within the SDK. They hand those to keepers, which control access to the KV stores and the underlying blockchain. And when I was talking about that component that talks to Tendermint, the keepers have very direct access to that. And the keepers update the state. So we'll see this flow quite a bit. If there's any questions, please feel free to ask them. I do know that the terminology can be a little daunting at first. So what messages are we going to define in this module we're going to creating? People need to be able to do two things. They need to be able to buy a name. You can buy a name that's already been bought, and that's like bidding more for a name, but that's the exact same message as buying a name. And then once you've bought it, you need to be able to set the value of that name, i.e. what does this name resolve to? When I call Whois, does it give me 8.8.8.8 for Google's DNS, or does it give me foo? And we need to be able to set that. So these are the two messages that our name service is going to have. So again, for this general flow here and kind of how these messages will flow through the application, and we'll see this in code in more detail here in a second. A transaction contains messages. Tendermint nodes, so once the transaction comes in with the messages, those transactions are sent down to the Tendermint node, which will include them in blocks. And that's passed down through the ABCI interface, which is the application blockchain interface. If anyone has any specific questions about that, we can dig into that afterwards. But one of the real beauties of the Cosmos SDK is that it abstracts the need to deal with this interface away from you. It's very low level, but it does give you everything you need to build complex state machines. The decoded, so they're passed to ABCI, and then when they come back, when they're included in blocks, they're decoded as messages and routed to the correct module to be persisted in state, and for those state transactions to happen to them. And those state transactions are called handlers. So when the message is handled, the state is modified. And the handlers call these keepers, which are sort of the abstraction that's at the core of the module, to modify that state. Any questions here? I'll just pause for a second. Cool.
Just like 10 seconds.
Yeah. And I would note, if you want to take a peek at where this code is in the application, modules are by convention held in the /x directory at the root. So all of these underlined things here will have their own named .go files. And we'll dig into those in more detail throughout this tutorial as well. So how does this whole application come together? There's all these components. We've got these modules. We have this base app thing. We've got Tendermint, a bunch of stuff that I don't know what it is. And we need to stitch it all together. So by convention in Cosmos applications, you do that in a file called app.go. And this is where you wire everything together. And it does logging, authentication, database management, Codec. So within the Cosmos ecosystem, we have a specialized encoding format to do persistence as well as over the wire. And app.go is where you'll deal with a lot of the encoding format stuff. Basically, it's a lot of boilerplate where you're wiring together the different pieces of your application. So if we start in app.go, we're importing a bunch of the tool chain, basically. So if you can see up here, we're going to import some stuff from Tendermint, so some logging utilities. This is a module from the Cosmos SDK. So as I mentioned earlier, that X convention there, modules are stored under X, and this is the auth module. So obviously, if we need accounts, it's one of the first things we need to wire up because the nameservice module that we're going to create later needs accounts in order to make these name to value mappings because names need to have owners. And then for the ability to have tokens, you need to have the accounts to use the bank module. So that's one of the first things we need to import. And then base app, and then the database manager. So if you're following along in the tutorial, there's in the SDK application tutorial repository, there's a /tutorial folder, and it's got a bunch of markdown files in there. There's a first app.go or something like, or first app.md or something like that that shows you the basic app.go. And that just, all it does is instantiates base app, i.e. your connection with the underlying Tendermint data store, and allows you to wire up additional modules to it. So it's just very basic. So once we've got that, let's step back and start talking about our nameService module. So modules go in the directory called /x, and if you're following along, you can see x/nameservice in that SDK application tutorial. And inside there, we're going to have a bunch of Go files named after things we've started talking about already. Handler, that's where the messages are going to be handled, and we'll define our state transitions there. Keeper.go, this is where the core of our module lives, and where we will define the getters and setters for the most basic pieces of state update. Querier, this is where, so the handler handles transactions, the querier will handle queries. So for querying this custom state, you might need to write custom logic to return lists. Let's say you want a list of all the names. All of that stuff is going to go in querier.go. Msgs.go will define the different messages that our handlers will handle, which is just essentially the JSON structure of the transactions that users will submit here. Codec.go is a little bit of housekeeping, and then the SDK has nice hooks to generate REST routes and CLI stuff, and hook that into a nice CLI experience very easily. I'll pause here. Any questions? Am I going too fast?
Why X?
Pardon?
Why/X?
I don't know. That's a great question. I don't know. It's I've seen it in other projects, and I know it's like short for something that I can't think of right now.
Oh, it's just not. It's not a variable.
No, it's just like modules go in /x, and yeah, I don't have a great answer for you there. I'm sorry. So the first piece that you're going to want to think about here, and obviously is it's kind of the most low level, and it's the most fundamental representation of your module, is the keeper. These are the getters and setters on the database, essentially. And your handlers are going to call these keepers in order to mutate state. So this is the base of the application here. Has anyone written JavaScript before? Any JavaScript folks in here? Anyone familiar with Redux? Okay, cool. So keepers are like reducers in Redux or mutations in Vuex. And then handlers are like actions, if that makes any sense. The handlers actions piece, I totally get. The reducers keeper thing is a little bit fuzzier for me, but that's just me personally. So we talked earlier about the value mappings that this keeper will take care of for us. And the first is name to value, i.e. what is the value of the name when we resolve it. That's going to be a key. And each of these value mappings in the database will have a key that gives access to it. And this is how you can give delegated access to other modules to access functionality in this module without giving all of the functionality of the module. So you can really precisely give permissions to different modules within your application. And then there's the owner store key. So there's an account address to name mapping, what account owns what name. And then the prices store key. How much does the name cost? And then as far as getters and setters, if you're following along in the code, this is in x/nameservice/keeper.go. So what would we need to do here? We need to resolve a name. That's get a name. We might want to answer if a name has an owner, because there's going to be some custom logic we want to do if it does, and there's going to be some other logic that we want to do if it doesn't. We also want to be able to get the owner and the price. So these are our getters here. They're all basically get X, except the has owner one, which is just a Boolean operator for convenience. And then the setters, this is writing data to the database, set name, set owner, and set price. Pretty simple. So let's look at one of these here. So this get price here, we're going to pass in the context. So the SDK comes with a lot of nice tools for working within this framework here. Obviously, it wouldn't be an SDK if it didn't. So let me just talk through a couple of these objects here. the getPrice function takes context as an argument. Context has all kinds of useful information on it, like block height, all the chain parameters from Genesis, like a bunch of useful stuff for you, where you are within the block. There's this concept of begin block. At the beginning of the block, you want to call a handler. As you're including transactions, you want to call a handler. At the end block, you want to call a handler. The context has where you are in that flow, along with a lot of other useful things. I would encourage you to look at the Go docs for that if you're more interested. We have links on the SDK. And the name. So obviously, if we want to get the price for a name, we need to give it the name. So first, we're going to check if it has an owner. And if it doesn't, we're going to return the base price, which is 1 coin. Obviously, it says my coin here, but that can kind of be parameterized out and given whatever denomination you'd like. Pretty easy to work with that code there. So once we have the name, we need to get the store. So we're going to create a new KV store with our key there. And if you pass the key into this KV store constructor anywhere in the code, it will give you access to that on disk. And then we're going to get the name from the store, unmarshal it. And I talked about the codec earlier. So this is an example of us using the codec to do some unmarshaling. And then we're going to return it as a specified type. And that type is SDK.coins. So the coin is just a value denomination pairing. Pretty simple, but there's a lot of functions on there where you can do addition, subtraction on coins, multiplication, all sorts of fun stuff. And then setting the price, so that's a getter, and then the setter, we're going to pull that store again, and then we're going to set the name equals to the marshaled coins price. Any questions there?
Get price isn't a query?
Pardon?
Get price, the keeper there, that's not a query, that's a keeper?
Okay, so that's a great question. So that is a query, but it's a method on the keeper. Does that make sense? So this is Go syntax for we're defining a method on this object. Mm-hmm. So the getPrice method, you need to have the keeper in scope to call the getPrice method. And then the getPrice method takes 2 arguments, the context, which gives you all this useful information about where you are in the SDK, and the name to pull that out. And then we've got the types that I just talked about. Does that make sense?
Yeah, I guess I'm wondering, since that's a getter, what are the queries for?
The queries are for returning user-facing data. So this is like low-level stores, getters, and setters, and maybe we need to use the getPrice, the getName, and the getOwner and return all of that data at once for just a generalized query. So we would stitch all those things together in a querier and return that to the user. And we'll see that in just a minute.
Your slides may be out of date, I think.
They're fading?
No. The previous slide, the code doesn't correspond to the code in the repository.
It does. Okay, so this needs to get updated. Thank you for the heads up there. I appreciate that. Shouldn't be updated too much, should it? A little bit. Okay, thank you. Well, I'll check that out in just a second. So trust what's in the repository. Don't trust my slides. So now we're on to messages and handlers. Now that we've got the keeper, we can get and set all of our values. Let's create this user-facing interface that we're going to offer. So messages trigger handlers. These are like user-initiated events. You can think of this as a click in Redux. Handlers call keepers, again, like actions, and then reducers. So just that same thing. Keeping this in mind, here's the interface that every message needs to satisfy. Who's familiar with interfaces in Go? Okay, most folks. For those who don't know, an interface just defines what methods an object must have in order to be included in a specific piece of code. So here we need a type. This type and route are used to route the message within the SDK to the proper handlers. Base app pulls the type off, gives it to the module, and the module pulls the route off and puts it to the specific handler. Validate basic. So any simple validation that doesn't require access to state. Like if you can check that the person who signed it is the person who is supposed to own the name, That's something easy you can do in validate basic. And we'll see a couple examples of validate basic functions in this. But these are stateless checks of validity of the message, and they will return an error. Get sign bytes, so this is the byte representation of the JSON that you need to sign over. And then get signers will return all of the signers for an individual message. Obviously, multi-sig implementations, you can sometimes have multiple signers, so it returns an array of addresses. Again, our two message types. We probably don't need to talk about the first two. They just return strings. It's pretty easy. But validate basic, so this is a great validate basic example. If the owner is empty, then they can't buy it. Like, you need to submit an owner with your by name message set name. So if there's no owner on the name, then there's something wrong and you're not able to set it. And if there's no name or there's no amount of coins in the message, then obviously we want to reject that as well. So stateless checks on the validity of a message in validate basic.
Is validate basic called in check_tx?
Yes. Yeah. And this is called, so this is something you never really need to call in your code. The SDK calls it under the hood and will reject transactions like at the CLI level if they don't pass this. So it's just, it gets called under the hood in the SDK, and it helps you make sure that you're sending valid messages to the state machine. So let's think about how we need to handle this name. And again, the code may be different here, but this is the gist of it. So if the message owner, just stepping back here, somebody owns this name and we're setting the value on it. So let's say I've got jack.id and I want to set that value to jackzampolin.com because that's my website. So I would say if message owner is not equal to, and we're going to pull the owner of that name, then we want to return unauthorized because that person doesn't own the name. They can't update it. That's an error. And the SDK, so that SDK dot, that is the Cosmos SDK /types package. This contains many of the common utilities for working with the SDK, including errors that return proper results, along with logs that will be appended and stuff. So this is kind of the canonical way to do that. But if the owner is correct, then we want to use the keeper to set the name and state, and then return an empty result. So this is just a very basic handler. Any questions there? Awesome. So we just talked about handlers. Now we'll talk about some queriers. So the two queries that we want to have is we want to accept a name and return a value. And we want to return all the data about that name, the value, the price, and the owner. And we'll define two queriers for this. So that second one is the more complicated one. The first one is just going to call that getter, as you mentioned, and then return that data, essentially. So really kind of a wrapper method. But again, more complex logic is possible in these queriers. So queriers will generally take the format of having the context as an argument, the path, which is just like that type and route in the message interface. Queriers have a similar thing. Base app will route them to the module first, and then the module will route them to the query handler. And that's done in the path thing. And then the ABCI request query, this is some additional data that would come along. And then you also need to pass in the keeper so that you have access to that underlying data. And it returns bytes and an error. So you'll see in this code here, we use the keeper to pull each of the different things for a given name. And then we've got a struct that we've defined down there, and we marshal it and return it. So pretty simple. One of the nice things is all of the code within each of these abstractions for basic things is extremely simple. It does give you the flexibility to add much more complexity within each of these steps, but just following this basic thing, if you need to do pretty simple mappings like this, it's not overly complicated, which I think is quite nice, and it makes for very readable code. So this is the codec here. So this, you only need to register with the codec things that will be serialized into storage. So the only things that we're serializing into storage are these getName, byName, and setName. All of the other structs in the tutorial, including that Whois, we're not really putting into storage. We're essentially just JSON encoding and decoding them, so we don't need to deal with that. But suffice it to say, all of your messages need to be registered. This way, it's kind of boilerplate, and it lives in a Codec.go file. All of our modules within the SDK, you'll see this exact same pattern. If you want more information on Amino, please check out the github.com/tendermint/go-amino repo. There's a lot more information about the encoding format there, but suffice it to say, it's essentially protobuf with a couple of prefix bytes to tell you what the message is, and then it's protobuf encoding after that. There's some alternate implementations in JavaScript. If anyone's got any questions about that, I'm happy to answer those later. So now that this is like, these are the core interactions. We have this querier, we have the messages. If all I want to do is use the Tendermint RPC port, which is 26657, I could manually construct via JavaScript or whatever messages and queries that would work with this state machine. What we're doing now is just niceties for a user debugging via CLI or someone who needs to use a standard REST interface. And this just comes nicely out of the box. The CLI, I'll show you, is very similar to the Gaia one. Like, we built it with the SDK, so I tried to make it nice and modular so that you can swap these modules in and out, add queries and new message types pretty easily with the minimal of code. We use the Cobra library that's pretty common in a lot of large Golang projects. If you're familiar with things like Kubernetes or any of the HashiCorp projects, there's a lot of projects that use this Cobra CLI library. You'll probably recognize it. So we're going to create a couple of files here. Obviously, our user interface here is these queries and these transactions that we've created. So we're going to create a client folder, CLI, and then a query and a transaction.go. And then the REST server would go in client REST, rest.go. There's an abstraction within the SDK called this module client, and this allows you to export all that functionality from the module in a way that's easy to wire up at the end, and we can see that, and I'm happy to dig into details there because I wrote that code. And once we've done that, we got to stitch it all together in app.go. So we need to import and initialize this module that we've created, and hook the module in with the auth and bank modules, and that's really about it. It's not a whole lot. There is some complicated code in there for the init chainer. That code I don't really explain super in detail in the tutorial. Basically what it does is it takes this Genesis file, which contains the initial application state, including parameters, and brings it into the application. I'm happy to go through with anyone who's interested and talk through that code. There's also some additional code in app.go that talks about exporting state. So this would be how you would dump the state from the application and restart from a specific block height. That logic we haven't packaged up nicely so that it's really easy to write like the rest of the SDK. That's definitely on the roadmap, and if folks have questions about that, I'm happy to answer those. But if you guys are familiar with the way that we did the hub launch, we had this long list of addresses where people had donated for the fundraiser, and we also had folks from Game of Stakes come in, and you put it all together in the Genesis file, and that bootstraps the application. So not really going to get into detail on that here, but happy to talk about that a little bit more. And then finally, we need to build our binaries. So with Go, the convention is binaries would be in the CMD folder, and we've got two of them. We have an NSD, which is the daemon that runs our nameservice module, and then we also have the NSCLI, which is the CLI that you use to interact. And we talked about building that there. And then we've got the makefile. We're currently using dep for Go dependencies. We've just switched the SDK over to Go mod, and all of the rest of it will be going with Go mod in the future. This is a Go dependency, minimal issue. Probably no one's interested there. But yeah, so happy to dig into more detail there. But first, let's go to, everyone can go to talkshop.name. And I've got a server running there that has a Namecoin chain running. And you can use the faucet. If you run make install, I believe, from the root of the application repo, you should be able, the SDK application tutorial repo, you should be able to build these binaries, just build off of master. And the commands that you can run are here. If you'd like to use nscli config to preset some of these config things like node or chain ID here, you can do that as well. And I'll just go ahead and pause here for questions. I have the repo loaded up. I'm happy to dig into any individual piece of the code. I kind of didn't really go into detail on the CLI stuff towards the end because it is a lot of boilerplate. But I'm happy to show that and sort of talk through the flow there as well.
Does the CLI use the REST API to track with the chain, or is it attempting to be like a full light client?
So the CLI uses the REST interface on Tendermint to query all this data. The REST server itself is going to aim to be a full light client eventually, and the CLI will have some light client features. Currently, we're undergoing some changes on the Tendermint side on how we're returning those to clients, and we haven't updated the SDK right now. So that's something that within the next couple of months we should have available within the CLI and the REST server. Any questions here?
Yeah, how do we actually use this?
So you need to build the binaries locally.
So
And
you said run make.
I believe it's make tools, which will download dep for you. And then it's make get underscore vendor, VENDER underscore deps, which will download all the dependencies for you. So there's a number of Go dependencies. It's fairly heavy. And then if you run make install, if you have your Go path properly configured, you should have NSD and NSCLI in your path. And all you really need is NSCLI to do these queries or by a name. And if anyone needs some tokens, there's a faucet here. If you want some more tokens, I can find a way for you guys to send me addresses, and I have access to the faucet wallet as well, so happy to send those. Let's see, has anyone bought a name yet? All right, well, this updates every 5 seconds. I'll leave it here while we're chatting details. So as far as those core components there, the keepers, the handlers, and the messages, does anyone have any questions about that piece of it? Well, let's see here. So I mentioned the CLI. So this is kind of what the general shape of the CLI is within Cosmos. Config allows you to set configuration parameters. There's a lot of common flags across the different commands. This allows you to set default values for those very easily. And you would just say key value. And then config just writes it back to you. So as I mentioned, there's the queriers and the handlers. In the CLI, that is kind of broken down into query and transaction. So you would say NSCLI verb module, so tx, can't type, tx, and then all of the different modules we have here. Auth and bank don't have a prefix because they export very little functionality, sign essentially. But nameService contains the messages that we just defined here. So by name and set name. And let's say I want to buy name. So the name, let's say jack.id, and the amount, I think the coins here are name tokens. So I think I'm going to say 1 name token. Oop. And then I need to pass it a from. Need to get that error message fixed. And include it in a block, and there's my name. Now to set that name, two arguments. We need a name, so jack.id, and I'm going to just put in my website here. From would be what key we're using to sign this message. So I have the jack key here. We do want to broadcast that. All right. And now it's got the value of my name on there. Is anyone having issues getting the CLIs built or connecting with the server at all? Oh, Myrnal, next. Winner, winner. So if I wanted to buy Myrnal's name, I would say nscli tx name service.
Yeah, I need to go erase the SD.
Ha! Oop. I need 2 name token. All right. And if you'll notice, the address there should switch to the new owner. Yep, there we go. Awesome. Cool.